This lesson is about series, and they're going to be arithmetic and geometric. And the difference between a sequence and a series is that a series is the sum, where you're taking all the terms that you have and you're adding them together to find the sum. So the sum of the first n terms of an arithmetic sequence, the formula is listed here as S sub n equals n over 2 times a sub 1 plus a sub n. Remember, n is the number of terms, a sub 1 is the first term, and a sub n is the last term. So this one is last term known. And then there's also one, I'll write it up here, which is S sub n equals n over 2 a sub 1 plus n minus 1d. And this one up here is last term unknown. And then we have our geometric one for a finite geometric, and then for an infinite. And when we get there, if the series has an absolute value greater than or equal to 1, there is no sum. Okay, so the first thing that you do is identify if the sequence, we're finding the sum of those terms. So this one is arithmetic. So we're going to use the formula to find the sum of the first how many terms. We don't know how many terms there are, so we're going to work backwards using the formulas from yesterday. So 24 equals 8 plus n minus 1, and the common difference is 2. If I subtract the 8, 16. 2n minus 2, and if I add 2 and then divide by 2, there are 9 terms. So to find the sum of the 9 terms, I'm going to put 9 over 2 times first term 24, 8, sorry, last term 24, and the sum of that is 144. And then in this one, this is a geometric sequence. Put a little negative sign here. The R, there are going to be n. There are 11 terms. Remember, that's 4 to the 0, so 0 to 10 would be 11 terms. And for the sum, we would take our first term, which is a 4, and then 1 minus negative 1/3. There's a negative there. Raised to the 11th, all over 1 minus negative 1/3, and you put that into your calculator, and the sum there is approximately 3. Now here, this is sigma notation, where k starting at 1 going to infinity, so this is an infinite geometric sequence. And so we have to check the R. So our first term, a sub 1, if you plug in 1 for k, that would be 0.75 to the 0. A sub 1 is a 3, and the R is 0.75. So this 0.7, the absolute value of 0.75, is less than 1, so therefore there's a sum. And then we use the formula, so S equals 3 over 1 minus 0.75, and our sum is a 12. And then over here, this is also a geometric sequence, and if we start with our R, we have to check pi over 2, the absolute value of pi over 2. That is not less than 1, So no sum exists. Okay. Now, the next thing we're going to do is look at this next one. This is an arithmetic sequence, and we're going to find what we need before we plug into the formula. So we need the first term, so a sub 1. So if I plug 1 in, 4 minus, actually we're not plugging in 1, we're plugging in our first value, which is a 2, and that's negative 2. And then we're finding the last term, which is 9, and 4 minus 3 times 9 is negative 23. And then how many there are, n, we're going from 2 to 9, so that's 8. So I'll put my work over here. So the sum of the 8 terms, 8 over 2, negative 2, plus negative 23, and then that gives us negative 100. So be careful where you're starting. You're plugging in the first term, but I is starting at 2, so be careful for that. Now what we're going to do is write the repeating decimal. So if we stretch this out, this would be 0.234 plus 0.000234 plus ... So this makes our first term 0.234, and our R 0.001, and then we use the formula S equals 0.234 over 1 minus 0.001, and the sum is 26 over 111, and that is our fraction. So on this one, it would be 0.0057. So a sub 1 this time is 0.57. R is 0.01 because there's only 2 repeating decimals. And then the S is 0.57 over 1 minus 0.01, and that's 19 over 33. And that'll do it for this lesson on geometric and arithmetic series.